Hello, and welcome to a midweek episode of the Batteries Included podcast. I'm Domenick, and my co-hosts today are the illustrious Tom Logney from State of Charge and the industrious Kyle Connor from Out of Spec Studios. On today's show, we're pleased to be joined by Ben DeLand, Director of Hardware and Engineering at GKN Automotive. So, welcome everybody.
Hey guys.
Thank
Good
you.
to see you. All right. So GKN Automotive is a multinational manufacturer of driveline components, all-wheel drive systems, and plug-in hybrid systems for the automotive industry, according to Wikipedia. But the GKN website says on its front page that GKN Automotive is a world-leading global automotive technology company that pioneered electric drive systems and is now driving the future of transportation. So that says to me that GKN is really leaning into the electric future. And of course, those products are what we want to talk about. So Ben, maybe if you could start by just giving an overview of what GKN produces in the electric vehicle realm.
Sure. So for electric vehicles, GKN Automotive provides anything from full systems, full electric drive unit systems. So that would be in the industry lingo, 3-in-1 systems, inverter plus traction motor plus gearbox. We will also supply individual components to our customers. So there are instances where customers would like to do the system in-house, but they're looking for a gearbox partner or they're looking for a traction motor partner. So we are supplying those components as well. And more recently, as we have seen the electric vehicles improve in sophistication with lateral dynamics, we see more and more requests for the components that are allowing increased stability, increased agility, increased traction that you would see in all-wheel drive systems. They're requesting them as components to integrate into the electric drive systems. So kind of a full suite there. And I also need to mention the core aspect of the business, going back to the 1950s, is with drive shafts and CVJs, which is completely agnostic for us between combustion engine vehicles and electric vehicles. So they're also a big player.
The CVJ is constant velocity joint, just for everybody
thank you.
There. No problem. No problem.
It's very easy to fall into the acronym world. I have to catch myself. Yeah.
That's cool. So GKN does a lot of like packaging as part of the whole deal with the in the early days, manufacturers were putting just like the motors. This motor was a thing, and then a gearbox was a thing, and then the inverter was a thing. But that's the olden times now. So now everything's tightly integrated into small packages. And there's a lot of companies doing this now too, right? It's not GKN. So what kind of advantages can GKN offer in that with that product?
Yeah, so we've been supplying electric drive systems for over 20 years. We've been on some of the earliest EVs there, largely in gearboxes. Early on, there was some interest in two-speed systems for increasing the speed output from electric drives. So things like the BMW i8 had a GKN system on it. And then, the past 25 years, we've been developing all-wheel drive systems for customers as well. So the systems that are managing the torque to the rear wheels, typically with front-wheel drive primary drive systems. So with that level of expertise on all-wheel drive and understanding both vehicle lateral dynamics as well as the vehicle integration capabilities that we've had from that experience with understanding how a vehicle needs to feel, how to manage that stability and traction and agility in the vehicle. That is really the wheelhouse that GKN belongs in. And really right now is an interesting time for that in electric vehicles, as I think we have seen that the first generation of electric vehicles, if we can call it generation, focused on longitudinal dynamics, so matching the front axle to the rear axle and really focusing on acceleration and speed. And now we see kind of that shift toward the lateral dynamics where all-wheel drive and those stability, agility, and traction are so important. And also a wider range of vehicles with off-road EVs coming. So we see GKN's experience with gearboxes and lateral dynamics as the right place for us to play.
Right on.
Well, I guess Domenick, sorry to interrupt, but I just have I'm just curious. So Ben, your role within GKN, so like your specialty, you were mentioning a little bit off camera, inverter technology, some other things. Like, what is your day-to-day like expertise in the company? What are you working on?
Right. So my role at GKN Automotive is Director of Electrical Hardware Engineering. So what's encompassed in that responsibility are any electronics that GKN Automotive is developing. So that could be all-wheel drive ECUs to manage the clutches and all-wheel drive systems for transferring torque. It's also inverters in the electric drive unit systems that we're selling to customers as well, along with a wide range of the low voltage electric components that would go into the systems. So these systems need sensors, they need harnesses, they need small actuator motors for shifting or for parking, things like that. These are all managed within my team as well.
So the big hot topic is, are you pro physical park lock, parking pawl, or are you an parking brake kind of guy?
Well, I'm sure my my comms team would like me to say that I'm pro park lock because GKN Automotive has a lot of expertise in park lock, but the jury's still out on that. We see a lot of requests both ways. We haven't seen a lot of legislation step into that space yet. As a consumer, I don't think I have a preference either way. It's just important that my car is able to go into park. I think, there are costing advantages for removing the park lock, of course. So I guess from a consumer standpoint, if that cost down is passed down to me, then that makes sense.
Yeah, but also there's always some drivetrain slop and stuff. So if you throw it in park, you'll get a rocking motion and actually I was driving a new Cadillac Lyric the other day and it had a physical park lock and it has like a Tesla style shifter and I have a Tesla and I'm so used to like at a half a mile an hour hitting park and just nice brings me to a stop. And I hit park in this Lyric and I was like, boom, facing the dashboard. And I'm like, oh, dang, can't do that. So I'm very much pro parking brake kind of guy, but no, love it. That's really cool. Yeah. So Domenick, I don't know if there's any particular topics you wanted to get into, but I'm ready to nerd out with Ben.
Well, I had a similar kind of question in a way. So you're talking about off-roading, and so Kyle's done some off-road tests with different electric vehicles, and the virtual lockers. Are you pro virtual lockers or pro physical lockers? Does this make a difference to you?
Yeah. I don't think I have let's say, the driving experience to like Kyle would have to explain, what that feels like in the vehicle. So, physical differential lockers, I would say, are where GKN is largely playing. But if that can be done virtually, then yeah.
So far, we haven't seen the virtual ones work. They haven't worked out so well. I'm not sure. Maybe Kyle can give us a little more color.
Yeah, I mean, I think it's such a unique use case, especially with a Rivian-like system where they use a Bosch supplied motor, 4 motors on each wheel, and then the software to tie it in is done by Rivian, which feels separate from the motors. And you basically have to stay in throttle, let it figure out, oh, a wheel is spinning, and let's juice up the other motor. And how much do we juice up the other motor? whereas I'd rather just have lock and apply nice consistent throttle and get it to move. Hummer EV is actually the same way with the 2 motors in the back. It's a tri-motor system. And actually, I have a Model S Plaid, and similar weirdness with this 3 individual motors for 2 rear wheels. But we're seeing this trend in high-end performance electric vehicles to go with a disconnected 2 motor system in the rear. I'm actually just thinking my Polestar 1 is the same way. So, I go into a corner, you can apply constant throttle, and I'm feeling that outside wheel push me harder than not. I don't notice it so much in the Model S, but a lot of what you're doing is around vehicle dynamics controls, handling the vehicle in certain environments. We're starting to see more user customizable, chassis control settings. Okay, we want more yaw, less yaw. We want, maximum longitudinal acceleration in some cases, or we want to derate power to increase thermal longevity. What are the compromises on a high-end performance EV that you're talking to your automaker partners about, saying, look, we can make an inverter handle a full track day, but it's going to be this big? Or what are these compromises in the performance sense?
Yeah, absolutely. So you kind of touched on it already with the virtual locker versus a physical one. The virtual locker in that case with the dual motor is just going to be a much more premium product there from a cost standpoint. You're making packaging. Packaging is more of an issue with that dual motor as well, right? So when we're looking at performance, it's certainly packaging, it's certainly cost, it's it's how you're managing the thermal, whether it's oil cooling that is integrated in your system, or water cooling, water glycol cooling that is supplied by the customer. These are the types of discussions that you're having up front there. The way that we kind of look at it, I mentioned that the traction, stability, and agility, you can kind of walk through those different areas. When I say traction, it's about ensuring that you have wheel slip under control, right? And you can do that with a pretty basic all-wheel drive system. When we talk about stability, it's a step up in what that all-wheel drive system is doing, with a limited slip differential, perhaps. And then agility, you're getting into those solutions of dual motor, torque vectoring, and each step up there, you have a sacrifice to make in terms of cost and packaging. So it's really about finding the sweet spot with what the customer sees their consumer wanting that vehicle to be.
I'm gonna go a little bit less nerdy here, Ben. One of the things I get a lot of requests from my followers is people want to convert their cars to electric cars, their older cars, and they're looking for suppliers for drive powertrains and inverters and things. Have you considered? I assume that you just sell to like automakers now. You have big contracts and sell thousands and thousands of units. Is there any consideration of making like a retail division so people can buy your components, and even if they install them themselves? Because I know there's a lot of people out there that want to convert older cars to EVs, but they really don't have a source for the components.
Yeah, thanks, Tom. So we have had a lot of discussions internally about this point. And I'll tell you the key challenge for realizing something like that is homologation. So there are some laws regarding the types of volumes that you're allowed to produce before you have to meet these homologation standards within different countries. So if you're exceeding that limit, then the business case for doing something like that, it just goes in the tank, right? Because you have to do extensive testing that is region specific to show the government that you're meeting their regulation standards, right? So you have to be at really low volumes to be able to do this retail type market. And when you're talking about really low volumes, then you need to have something that's off the shelf, easy to provide, and keeping those volumes low. So those are the challenges associated with that.
Hmm.
So Ben, I guess, maybe more high level. What are the different types of drive systems that GKN provides from an electric standpoint? Obviously you're no longer doing physical center differentials and drive shafts front and rear. You're now doing virtual power split, front to rear motor. So you're providing a primary axle, a secondary axle powertrain system, and then tying that system together, or are you leaving that to the automaker to tie these together?
Yeah, so it's really, it varies a lot between different customers. So I think we've seen a lot of customers do insourcing of system responsibility, at least for their electric drive units, particularly on the primary drive axle. GKN's experience, or the systems that we have out there, largely are secondary units, not exclusive to secondary drive axles, but because we have such a strong all-wheel drive heritage, and secondary axles are what is providing that all-wheel drive functionality in EVs, that has been kind of our sweet spot, let's say. And in terms of what that integration looks like, it varies so much from customer to customer on what they want to handle themselves, what they would like the supplier to handle in terms of vehicle level integration. So we're quite flexible on that, I would say, even with just bringing components in, just a gearbox, or just a traction motor, or just an inverter. So wide breadth there. I know it sounds like a political type answer, but it is the truth.
Yeah. So when you guys are working on secondary axles, can you actually say what products your motors are going into? Like, is there anything that's been publicly announced so our audience can get an idea of what's powered by your stuff?
Yeah, sure. So I think that's fair for production units. We have the secondary axle on the Ford Mach-E, for the all-wheel drive version. We have the primary drive on the Fiat 500e, is a really popular vehicle, especially in Europe. We have some of the Land Rover hybrid vehicles there. Yeah, several more examples.
Sure,
That's,
but
that's,
that
that's kind of.
go ahead, Domenick.
I was going to say that's kind of neat that you'll make the secondary axle for like the Mach-E, but so Ford is making like the other axle, like the primary axle. That's like, so it's just kind of interesting that they divide things up like that. Yeah, that's something that I think that most of us don't really see behind. It's behind a curtain that we don't really get to know all that kind of stuff. That's
Yeah,
pretty cool.
exactly.
Most secondary axles, so like in my eyes, a perfect electric vehicle drivetrain setup, and I know this may not be like 100% your wheelhouse, but if I was designing an electric vehicle and I would say, okay, what do I want my powertrain to be, I would want a permanent magnet, typically rear axle, primary axle in the back of the vehicle, because I want the most rear bias possible, because I'm an idiot and like to go sideways. And then I would use an induction front motor, or a permanent magnet with a clutch disconnect on the front, so that you don't have flux related losses. But also, like, an induction motor should just run forever. Like, those things have very little problems, very little wear and tear. So is GKN, do you advise automakers on, let's do an induction, or let's do a permanent magnet with a clutch disconnect? And do you offer a disconnect function on your secondary drives?
Yeah, absolutely. So it's a discussion up front in the quotation phase regarding those trade-offs that you had just mentioned with induction motors versus permanent magnet motors. Yes, absolutely. GKN has disconnects with our permanent magnet systems to reduce the drag loss when that that axle is not needing to generate torque. The trade-offs there, when you look at an induction motor versus a permanent magnet motor, it's typically in package size, right? An induction motor for the same power as a permanent magnet motor is typically going to be a bit larger. The power electronics are agnostic, really. So my focus area,
Okay.
I don't really care whether it's an induction motor or permanent magnet motor, although an induction motor is not going to operate in generating mode where you're able to backfeed some power to recharge the battery. So let's say the duty cycle on the power electronics change, but fundamentally the architecture is going to be the same there. So yeah, it's just a discussion up front that's about packaging, that's about cost, disconnect systems.
So, Rook, is there a difference in the amount of regen that a permanent magnet motor can put out compared to an induction motor?
Yes.
Oh, I did not know that.
An induction motor is going to produce 0 regen capability.
Well, we've driven some induction-only motor systems out there that do allow regen. Audi e-tron is an example of a dual induction powertrain that regens, and I'm trying to think what else. So yeah, Mach-E, is that an induction front drive unit on there, or is that permanent magnet? Do you know?
It's permanent magnet.
Okay, yeah, that's interesting. And there's no disconnect. So Ford chose to go cost, packaging, and average that out. So Ben, can you tell us a little bit about the power electronics side of things? Because I feel like that's where maybe all three of us, but especially me, we're least versed on inverter technologies. What is going on inside that magic box? How is GKN different than your competitors such as Magna or eAxle or one of these, American Axle, one of these companies out there that's also providing drive units? Not to say it's a direct comparison, but why would someone go to GKN for your tech?
Yeah, sure. So there are a few interesting things happening in inverters, and I'm sure your audience knows what an inverter is, but
Maybe
just one
quickly,
statement
just
about it.
quickly, yeah.
Yeah, so the objective of the inverter is to take the power input from the battery, which is at DC, and to invert that power to three-phase AC to drive the traction motor. So the traction motor is having some a stator there that is needing to be electrically excited to create a magnetic field to propel the motor. And that's what the inverter is doing.
So does the inverter get the signal from the accelerator pedal, or does that go to the battery, to the motor?
It's coming to the inverter.
Right. Okay.
Yeah.
Just laying that out there.
So
Yeah,
a lot
perfect.
of the fine tuning is done in the inverter to maximize the motor's capabilities.
Yeah, well, it's all software when it comes down to that, right? And the software resides in the inverter on the microcontroller.
Speaking of like software and hardware, inverters also. So there's different kinds of inverters as far as like materials used to make them. And so I think traditionally we use like IGBTs or something for transistors, and that's really transitioned a lot to silicon carbide inverters, which are more efficient and can handle the heat better, I guess. Or maybe you can tell us a little bit about that and maybe what you're doing with that, and maybe also like the voltage areas where you play. Like we've been seeing a shift from 300, 400 volts up to 800 volts. So yeah, maybe you can see where the whole industry is going as a whole, because we have the impression that everyone's going to like the 800 volts or higher. So, but maybe you have a better point of view here.
Sure. So let's talk about the voltage point first.
Okay.
So power for electric power, it's a simple formula. Current times voltage equals power. So if I have a 200 kilowatt system, my relationship between voltage and current is linear to reach that 200 kilowatts. When I talk about power losses in the system, the key factor there is the amount of current that you're using. So current with resistance is what's determining the losses in your system. So ideally, then you want to push the voltage up as much as possible and the current down as low as possible and achieve the same power there. So that is, from a basic view, what's happening there in the shift from these 400-volt architectures up to 800 volts is you need less current to produce the same amount of power. Therefore, you have less losses in your system, losses from heat, from resistance in your system there. So yeah, the trend to lead to greater efficiency of these electric vehicles is increasing the voltage there. So 800-volt architectures are becoming quite common now in development. The question would be if we're looking to take a step beyond that to a kilovolt or maybe a bit higher than a kilovolt. Of course, you can't continue on this path without some other trade-offs. It's
Right.
not an infinite increase there that you can make. You start to hit physics-based limitations with arcing of voltage, maintaining clearance and creepage type of requirements in your power electronics and the traction motor. So HV, high voltage safety type concerns there. But I don't believe that we're done at 800 volts. Of course, we already see Lucid vehicles at 900 volts. I think there's still some room to grow there. When you were talking about IGBTs versus silicon carbide, what you're talking about there is the power module inside the inverter. So it's the part of the inverter that is converting or inverting this DC input into an AC output. It's the component where there's the most losses in the inverter, and it's generating a ton of heat. It's quite a large component as well. It's by far the most expensive component in the inverter, so it's the most critical piece there. So IGBT stands for isolated gate bipolar transistor, and silicon carbide are MOSFETs, or metal oxide semiconductor field effect transistors. So they're both transistors in the end. They're switching very fast, 20 up to 20 kilohertz or so, to produce these AC waveforms that are driving the traction motor. The difference between IGBTs and silicon carbide MOSFETs, you alluded to it already. Silicon carbide is allowing, it's having better efficiency, so lower conduction losses. It's allowing higher switching frequencies that allow some better controls mechanisms for the traction motor. And it's more thermally hardened than IGBTs. So that comes at a cost to step up to silicon carbide there, but it's a cost that is still coming down, I would say, as volume is reached with silicon carbide MOSFETs. And it's one that often our customers are willing to accept or wishing to have, really, for those efficiency benefits.
So, Tom, go ahead.
Yeah, Ben, so I have more of a business question than specific engineering. GKN's been in business a long time, making automotive components for OEMs for many, many years. With this new electrification wave now, what I hear from other suppliers is that it's like the Wild West now, because the pace at which everything's advancing is so rapid that many companies aren't used to this, and they have to hire new engineering teams, because it's like what technology that's cutting edge today, next year's old hat. And that really wasn't the case for decades. How do you deal with that? Could you talk a little bit about, is this did you have to bring in new engineering teams, or is it just business as usual for you guys? Are you just used to this and this is what you do? I'd like to hear your opinion on how you're dealing with this electrification transition.
Yeah, so it's absolutely not business as usual. So I think in the past 5 years, we've worked to transform our engineering organization to deal with the complexities of an electric drive unit complex project that is requiring massive numbers of people to execute, really. You know, when our focus, at least when our mechatronics focus was with an all-wheel drive system. All-wheel drive systems are interesting as a middling functional safety set of requirements there. There are a lot of vehicle integration type aspects, you know, cybersecurity, things like that. But the challenge, the step up from all-wheel drive systems to electric drive systems is real. So we had to transform our engineering organization to be much more system engineering disciplined. So we have a systems engineering department that I think is top class there. We've organized by function in our organization to allow, you know, depth of expertise in these different product streams, and yeah, project management for managing these really massive projects. It was another key focus that we had to transform. So it's absolutely different, transformed, and continuing to change based on the needs that we see to execute these.
Go ahead, Kyle.
Thanks. Okay, so back to the inverter nerd stuff. Okay, so you have different types of switching technologies when it comes to transistors. You have silicon carbide, you have IGBTs. Is there anything else?
Yeah. So the hot discussion right now is regarding gallium nitride.
Right.
That's being discussed as what's coming next. So gallium nitride is interesting. So up to this point, it's been for lower voltage levels. So you know, 400 volt levels have been okay for gallium nitride. We're starting to see some advanced development now that would be able to support 800 volt architectures going forward. Gallium nitride has the benefit of being able to switch at much higher frequencies than silicon carbide. That's and it, in terms of manufacturing gallium nitride power modules, it's expected to be more cost efficient than silicon carbide.
Oh, really?
So that's kind of an interesting selling point with gallium nitride. So the higher switching frequencies, the much higher switching frequencies are maybe not as much an advantage for driving the traction motor, where you get some diminishing returns on that and actually more losses in the inverter.
Mm-hmm.
But possibly what it's going to do is allow further integration of other systems into the inverter, things like charging systems or DC to DC converters, where that switching, high switching frequency is actually quite a benefit for those types of systems. So it's maybe an enabling technology for some further integration and providing some cost down benefits as well for the traction motors.
That's kind of like the architecture that what you would call AC. What was the people the AC propulsion? Yeah, they had the charger wired into the inverter at the same time. This is like a long time ago, and obviously it hadn't really progressed since.
Well, the
like,
Tesla Roadster works that way too. It charges through the PEM, through the inverter, and into the battery. We've seen it on eGMP with their primary axle. They use silicon carbide in the rear, and they can do 100 kilowatt DC to DC boost function for low voltage DC equipment. But I think they're capped at, maybe around 100 and I'm trying to think, maybe 120 amps. No, it's got to be 200 amps, something like that, because of heat would be my guess in that rear inverter. Because I've looked, I've like spoofed some CAN signals off an eGMP using the booster, and the thing just goes right into the red. It gets hot. So that's my main issue. I love that you guys are working on this stuff, but I have to tell you, as a performance driving enthusiast who also loves electric, inverters are the weakest link for me at least. They spike heat really quick. It's hard to get them away. And I think that's a topic I definitely want to get your impression on, is what can we do to reduce the heat loss, increase efficiency, but also increase performance longevity of the inverter. And then also B, kind of understand where automakers are going. It sounds like in your case, a lot of them are choosing silicon carbide. To me, it almost makes sense. Like if you're going ultimate cost, if you're making a less expensive vehicle, maybe do silicon carbide on your primary axle and just IGBTs up front, which is, I think, how EGMP does it as well on their secondary drive. They don't use silicon carbide up front. So that's a lot of topics, but what's your impression on the costing of that, and then also mainly the real thermal, I would say pain point of the inverter?
Yeah. So the thermal aspect is a really interesting one to look at. So most inverters are water glycol cooled with an external heat exchanger. You typically would have a power module with some heat fins that is sealed into a channel with water glycol flowing in that channel over these heat fins to pull heat out of the die of the power module. Of course, an issue is that water glycol is conductive.
Right.
So you have to isolate them from the dies. One concept that several suppliers have looked at is if you use some sort of oil cooling in the inverter, you can expose the dies. So if it's non-conductive oil, you can get the cooling much closer to the dies there. So even though oil is going to be less efficient than water glycol at removing heat, the fact that the cooling is being made directly on the dies itself is an advantage. So that is one interesting concept that's out there that also kind of aligns with the integration of the inverter further into the unit, right? So having the power module closer to the traction motor, where maybe there's also oil cooling there.
So throwing things at it like a larger heat sink or something that wouldn't really necessarily take care of his cooling problems.
Yeah, well, it's also a potential solution, but it comes at a trade-off of increased mass and weight, for the system.
Right, but would
And
it actually would it work in a performance application though?
Yeah, there are several. So the power supply market the power module market is fascinating also. You have double-sided cooled power modules. We have some different technologies for sintering power modules to heat sinks. We see Tesla do this already to get more performance out of it. So there are absolutely a lot of different methods there for improving the thermal performance of power modules. And the market has not, my belief is the market has not consolidated toward the right answer there.
Okay. I see you guys are partnered with Jaguar Formula E team as well. So do you get any feedback on those systems for what you're doing in-house?
Yeah, so we have a couple of engineers that embed with the Jaguar Formula E team, so helping them out with some power electronics thermal consulting, and we allow them to test on our dyno rigs as well at our facility in England. So we're close to that team and share information back and forth.
Cool. So some of that could trickle down to the consumer market.
Yeah, absolutely. That's the idea of racing, right? Is that you have that innovation there that is far ahead that eventually makes its way into the consumer arena.
Right. Race on Sunday, sell on Monday is I think is what they say.
Yeah,
That's
Exactly.
right. That's right. Cool beans. Well, can't thank you enough for your knowledge. I mean, I think what would be kind of cool is just to hear your final thoughts on, okay, someone comes to GKN, an automaker, they say, help me out. I have my own primary axle or my own motor. How would you approach? I mean, obviously, the guys that you're dealing with at OEs know what they want. They say, okay, we have to hit this price target. We want this performance target. We need this thermal longevity. We need this, efficiency benefit out of your motor. But let's just say I roll up to GKN and I know less than nothing about electric motors or drive systems. What would you advise me to do on a typical, spicy, standard SUV that's out in the market, like a Mach-E GT or something?
Yeah. So if cost isn't a concern, and I think that's your question, I think having a dual motor approach at the rear axle provides you a ton of benefits that the driver is looking for. In terms of those three aspects that I talked about, stability, uh, traction, and agility there. You can do a lot with those dual motors for torque vectoring, for cornering to bias the outside wheel there to help you through turns. That's the ideal setup for me. And then I believe a permanent magnet motor in the front with a disconnect there is the best option. This is a personal viewpoint, right?
Mhm.
So I'm not speaking for GKN Automotive here, but a permanent magnet motor in the front with a disconnect system is providing the best packaging there for the front and the power density to make that a very fun vehicle.
I would totally agree. I think these dual motor rear systems are so fascinating to me because each one has just been wildly different that I've experienced. And so I have not driven the Lucid Air Sapphire yet. I hope to do so in a week or two because that seems next level, stupid, crazy, awesome machine. But I have a Model S Plaid with this dual thing. Have you had a go in a Sapphire yet, Ben?
I haven't driven it, but I've ridden in the back seat, and
Oh, no way. So what did you think? What did you think? Was it crazy?
it's incredible. It takes your breath away. You feel like uh, you, you do kind of like a guttural sound at a launch because your stomach rides up into your chest. It's a really fascinating ride.
Right
That's
on.
that's wild. I mean, the acceleration is crazy. My main concern with these dual motor systems is just like, um, so like, okay, so the Model S Plaid has, and of course the Sapphire has more than enough power to just roast a tire in the rear. So if I go, okay, drift mode in the car, whatever, I want to go sideways, I can get the car leaned over, do a quick stab on the throttle, and I've got big opposite lock. In my Rivian, I actually don't have that much power per motor to do that. Or at least there's some software limiting. Because even if I hit a drift mode function, I'll get the car leaned over, hit the throttle, and it spins inside tire and the outside stuck to the ground. And so for me, that's where a locker could help if you're undersized, where I could, almost take that extra power and send it that way, if you will, mechanically. So do you think if you're going to go dual motor in the rear, they got to be juicy? Like these things have to work?
Not necessarily. I think it's really coming down to the software controls and the tuning of that. You said that you can make the Sapphire, uh, spin, get the rear end coming out. That's all going to be based on how the tuning is made from the controls, right, to allow you to do that. And I think the controls for dual motors are still improving and optimizing for that consumer feel. I'm not sure if there's any options for selectability on that feel out there, but that would be an interesting thing there as well, based on, if you're looking for higher performance, agility around curves versus I want a really stable ride there. But yeah, I don't necessarily think it's about power. I think it's more so about the controls.
Great. Well, oh, that's fascinating. Thank you for all of the information on that. I mean, we could spend 5 hours talking about dual motor control systems. So thank you very much for all that.
So, one quick last question: where can our extra geeky listeners learn more about GKN, and maybe where can they stay updated on the latest developments over there?
Yeah, thanks for asking. So you can check out GKN Automotive socials. The LinkedIn social is very active. Also Instagram and Twitter or X as well. So check them out, GKN Automotive.
All right. Well, thanks again for your time. We appreciate it so much. It's great, and yeah, still a bunch of questions in my head, but maybe we come back another time and talk
Yeah, I would
some more.
love that. I
Oh,
really enjoyed nerding out a bit with you guys. So thanks for having me on.
right on. Okay, so I guess that brings us to the end of today's show. Don't forget, you can find and follow our panelists on social media. Follow Tom Malogny on Twitter at Tomolog, that's with two M's, or tom.malogny on Threads. Kyle Connor is on X or Twitter at It's Kyle Connor and goes by Virtual Kyle on Threads. And I'm at Domenick on Threads. And do you have a social media presence there, Ben, that people can find you on?
No, well, my LinkedIn is the most active, so you
Okay,
can find me there, Benjamin DeLand on LinkedIn.
right on. And it sounds like for GKN, LinkedIn is a place to go for that.
That's right.
Right on. All right. So thanks for watching. Click subscribe, tap that bell icon for notifications. Okay. And we'll see you all again next time. Ciao.